Hello. In this tutorial, we'll be showing how to use Cognalysis MultiRate to build a predictive model, starting with the importing of data. The data that we're going to use is from a data set out on the Kaggle.com website for house prices in King County, Washington. We've got identifiers for the particular house that was sold. We've got a date, price, etc. And what we're interested in is looking at the value of the home and what are our predictors for what that value would be. So if we were looking at this data in Excel, we could just make a pivot table and take a look at the information that we have there. We're primarily interested in the price here, so we could put that price there, and maybe we look at that price depending on the number of bedrooms. Maybe we change that to be the average value of the home. Add a little formatting here, and we can see that generally the more bedrooms there are in a home, the more the value of that home is. We have things like this where it looks like the highest value is at 8 bedrooms, but how many observations do you actually have with 8? We might look to add something like a count here, and it's showing us we only have 13 homes there. It's not terribly credible, not something that we would use to predict to say 8 would be higher than 9 or 10 or whatever. Similarly, we might look at a different variable here other than just the number of bedrooms. Let's say we look at the next one down the list, and instead of bedrooms, look at the number of bathrooms. Add that as a row field, and we could see that also we're seeing that as the number of bathrooms increases, the value of the home increases as well. So this sort of ad hoc analysis is okay for kind of looking at data and trying to get some sense out of it, but we're not really building a model at this point because we've got probably a strong correlation, for example, between the number of bathrooms and the number of bedrooms. And if we were to build relationships of what the price looks like based on increasing number of bathrooms and increased number of bedrooms and combine those together, we'd end up with a bad answer because we're basically double counting. And we've got a number of variables to look at. If we're going to look at all of these on an ad hoc basis, it'd be a bit tedious. What we're doing with MultiRate is giving you a framework to load data in and quickly see what the important impacts are. So I'm going to close this down without saving because I don't want to save those pivot tables. And I'm going to import this data instead into MultiRate. So I'm going to start a MultiRate session. And I'm just going to click on the file, import data. This message pops up when you first open the software. It is loading some things in the background, and that can compete with an import. So if you get this message, just click OK. We're going to select that particular CSV and click Open. That can be a flat file. It can be an Excel table. You can load from Access, or if you already have data in your SQL Server database, you can just go directly there. The first row of our data does have column names, so we're going to say OK there. And here are those same columns in the import screen. Basically you look at your data and decide, hey, there's some of these that I do or do not want to include. We're just going to include all of it though, and press continue. Okay, now it's asking us where we want to import this data to. The software works with SQL Server databases, and so we're just using our own machine here. The machine that I'm currently using has a SQL Server environment on it, so I'm just going to select that as the SQL Server. If you have a network server, you certainly can use that if you've got SQL on that as well. And in this case, we're just going to create a new database. You got a list of the databases that show up, but we're just going to create a new one here for house price. And also we need to say what do we want this table to be called. I'm just going to say input data. Click import, and it's loading that data in. This is a fairly small data set that's good for showing demos, but if you've got something larger, it may take a while longer for that to import. We'd like to start an analysis with that data, so we'll say yes here. So what that did was identified that database. Otherwise, we'd have to click the drop down, identify the data table that we want to use when building our model. And it's also asking, do we want to create a random variable, separate the data into training and test subsets? This is very important for predictive modeling because it helps us avoid overfitting to our data. What we're looking for are the true underlying relationships that give us predictive power, not simply to measure relationships that are essentially random. So we break the data into training and test data, build our models from the training data only, and then see how well the model does on the test data. When we compare alternative models to each other, we do so comparing them on the test data. Yes, we'll do that. So what that's going to do is randomly select, in this case, 50%, and it will give you a suggestion here for the percentage to use based on the size of your data and number of columns. Here we're going to use 50% of our data. So that created a new variable on that table. Actually, we can see it here called training set indicator, where it's, in this particular case, it's already selecting that for our training data, and using the other half for false. So now we're looking just at the training data, and we can see that 100% of it is true. We have our other fields here. If we select on number of bedrooms, for example, it's going to show us some information here on percentage. So the largest single value for that field is 3 bedrooms with 44.8%. At this point, we haven't told it yet what field we actually are trying to predict, what field is of primary interest to us. All it's done is basically said where is the data and break it into training data and test data. But let's tell it that we're interested in price, so we're going to set that as being our target field. That's what we want to try to predict. Next, we'll select the characteristics that we'll use in our model to try to predict the home price. We could go through and take a look at these different fields. Now, once I have a target field selected, if I click bedrooms now, it's going to show us something different. And so we could go through and take a look at all these. I'm just going to do select all. It's going to identify the different fields and how to categorize them. Notice we have a zip code field in here. It's automatically identifying that as something where it's zip 5. It's not including that training set indicator. The reason is 100% of the records have one value for it. Date, there's too many values. This was coded as text, and it doesn't necessarily know that that's something that's sortable. But the way they coded that actually was something that can be used, and so we're going to just include that as a grouped field. Generic characteristic here, which a lot of these are showing up, just means that each variable value will take a different factor. If we're grouping them, we're saying basically we're gonna group them together into bins first, and then come up with factors. So anything that's continuous in nature, such as this date, fairly continuous, you'd want to put in as grouped, and we've got some geographic fields as well. We'll go ahead and click grouped for that one. Notice that there's a default smoothing that popped up that's variable gradient. We won't spend a lot of time talking about that in this presentation. If you want more information about that, you can take a look at the help screen. Basically, that's saying we're going to smooth out between neighboring bins. We're going to look at neighboring values when we're building our model. We've got some other choices there as well, including no smoothing, which would be just select blank. But we're going to leave that default in there for here. Click OK. It's asking if we want the software to suggest a 50% credibility level. This controls how responsive the model is to the data versus filtering out the noise. We do recommend that we test out multiple 50% credibility levels, but we'll start with what it suggests. It's looking actually at the skewness of the data to come up with a starting point for that. But that's one of the key dials that you have as a modeler to adjust to take a look at what impact does that have on your model. So we essentially have a model here that we can run. It's calling this analysis price_1. But after this model runs, I actually want it to go through and try to refine that model for us. That's a process you can go through manually, but you also can use this improvement mode button. I'm going to click on that, And the default is none, meaning it's just going to do this model. You can take a look at it and try to do your own refinements of it. You can have suggest improvements where it's going to come up with a list of things to suggest, or you can just say auto improvement, which means it's going to take those suggestions and run an alternative version of the model and then keep going until it can't improve the model anymore. We're going to turn on a couple of different things here. One is investigate interaction effects. If we've got non-multiplicative relationships between different variables, this is going to try to determine where those are and test those. Also, we're going to delete extraneous analyses at the end. What this does is we could end up with 30 different alternative models that it builds here. Each is tested against the test data, and it's going to, in this case, eliminate all of them that were not best fit or simplest within tolerance of best fit or the initial model. So at most we'll end up with 3 final models. It's not going to keep all of the individual models, which helps cut down on having a lot of tables in that SQL database. We're going to click OK here. So now we're going to run this model. We're going to press this Start Analysis button. It's going to ask us where do we want to save this file that it's going to create, and we're just going to put it in this folder here. And then it's going to start our analysis. Pretty quickly we'll be able to see some information from this. We're not going to go into a lot of detail about what we see here. We're going to leave that for a separate tutorial because mostly we want to show you how you get up and running and how you start creating models. But basically it's telling you what variables it's finding to be most valuable up at the start of this and then wrapping around. So some of these are considerably less important, and that's something that's going to end up likely getting trimmed out later. But you can take a look through and see what sort of impact different variables are having on the price, and it's going to keep going here until the convergence gets down below a certain threshold that's been established, or until we hit the maximum number of iterations that have been set. Okay, jumping forward now, we've cut out a little time there, but you can see now that this convergence threshold we're getting close to achieving that, where our factors are changing by less and less as we look at from one iteration to the next. And when this drops below 0.001, what it's going to do is calculate fit statistics on the out-of-sample data and then come up with alternatives to do to these different variables based on what we're seeing on the training data. It's going to make some adjustments, possibly change the credibility standard, and then kick off our next model. And we should see that start to happen as soon as this drops down below 0.001, which is the threshold that we've established. Okay, so now it's going to apply these factors to our out-of-sample data, to our test data. It's calculating our fit statistics. It's coming up with suggestions. If we had it tell us to suggest improvements, it would pop up with a screen. But in this case, it just is starting now with a new version of the model. And it will continue to do that process as long as it can improve the model. And you can see there's quite a bit fewer variables here now. So now we've gotten to the point where it has finished the improvement process. This screen pops up, and we'll click OK there. Notice that its final model was price 2, and we can look to see what changes that it actually made. This doesn't mean that it's necessarily just the second one that was run. It could have actually written over that one. So we'll look at the improvement log, and we'll print that off. And in that, we can see a history of what changes it actually made. So you can see it actually created other files, but the best one that it ended up with was actually the second one. And you can see what it did at each step, changing credibility standard, changing breakpoints, on the bins, etc. This concludes this particular tutorial of how to get started building a model. Please check out our other tutorials on interpreting the results. And I hope you found this informative.